So the way to solve this equation, first of all, how do you know this is the equation here of the type here? So compare this one, okay? Compare this one with the equation I have dy dx plus px times y equal to qx times y power n. Compare this equation. So when you compare this, you find that this is a Bernoulli equation. Why? Because you have a minus x is your px now, and qx minus e power x squared is your qx now, right? What is n now? N is equal to 3 now. But compare this equation, n is equal to 3. Okay, so this is a Bernoulli equation. Okay, the n is the degree here is equal to 3. So what you do is divide both sides by 3. No, divide both sides by y power 3. Right? So divide both sides by y power 3. Get y. So divide both sides now. By y power 3. So then you get 1 using this standard equation as a reference here. Divide by y power 3, you get y power minus 3 dy dx minus x. Okay, 1 y power 1 divided by y power 3, you get y power minus 2 now. And then the other side, after divide both sides by y power 3, you get e minus e power minus x squared. Right? You get this equation. Then to solve this problem, then you have to let u equal to this thing. Look at here, this one. Okay, u equal to this one. So I let u equal to this one. So I just write here first because right, u equal to y power minus 2. Okay, this is how I'm going to simplify this. I want to get rid of all the y, and so that final equation have only u and x. Okay, so this equation I leave it there. So let's do a simple calculation first. Okay, so I start from original problem, compare what is the standard Bernoulli equation first, divide both sides by y cubed. Okay, then you get y minus 3 dy dx minus x y power minus 2, and then on the right hand side negative of e power minus x squared. And let u go to y minus 2, right? Y power minus 2. So let's do this, how to make use of this. Right? I'm going to show you how to let this. Okay, so my u is equal to y power minus 2. So how do you find differentiation of du dx? Of course, using the chain rule, you can differentiate. Okay, du dy first, then times dy dx. Okay, this is chain rule. Okay, chain rule. Now u is y power minus 2. So this differentiate y power minus 2 times dy dx now. Okay, so differentiate y power minus 2 using the power rule for differentiation. You get minus 2 y power minus 2 minus 1 and minus 3. Okay, so this is normal differentiation. Okay, differentiate y power minus 2 with respect to y. Then you got this. So this is du dx. So from here, what is actually dy dx now? So dy dx is equal to divide by minus 2 first, then multiply by y cubed, right? Then you get minus half du dx is equal to dy dx now. So dy dx is minus half y cubed du dx. why is this useful? Later on, I show you the why is this useful. Okay, so you start from u equal to y power minus 2, then you apply the chain rule. Okay, then differentiate u, you get y power, which is y power minus 2, you differentiate, you get minus 2y power minus 3 du dy dx. Then make dy dx the subject here. Now I'm going to go back to earlier equation to show you why this is useful. Okay, earlier equation is this one. Okay, earlier equation I have this one. Okay, this one is my earlier equation. Okay, involving y and x. I want to get rid of y now. Okay, so let's put here the earlier equation. So I need a new page here. So this is earlier equation, and my u is y power minus 2. I also have just now dy dx. Okay, dy dx is this one. Okay, let me copy this one. And dy dx is this one. Okay, so notice that what is dy dx now? Okay, dy dx is actually, okay, dy dx is this one, right? You can see the dy dx is here. Let me put a color, put a blue color here, put a blue color here. Dy dx is this one, right? Okay, this green color one is u. So now I put dy dx here. So this is equal to y power minus 3. Dy dx is minus half times y3 du dx. Okay, the dy dx is actually this one. And then the other one is minus xy, so minus x, y power minus 2 is u here. Okay, y power minus 2 is u here, so I use the green color one, so I get just substitution, and this is equal to minus e power minus x squared. And you have a log cancellation, right? You can see that y power minus 3 and y3 cancel. So you get minus half. Okay, so you get minus half of du dx minus x times u equal to minus e power minus x squared. Now I multiply minus 2 to everywhere. Okay, multiply both sides by minus 2, so that the number in front of du dx is 1. Okay, so you get du dx minus x times minus 2, you get 2x u. Okay, then minus 2 times minus 1, you get 2e minus x squared. So you get this equation. So this is the equation in u and x only, right? In u and x now. No more y. Okay, no more y. So we are trying to solve this equation in u and x now. And this is the type equation you can compare how to solve this. So after they got this already, so we have to recap again what is the linear equation. Remember what we have. Okay, I'm going to write this and let you compare. Okay, so select the 2 here. I want to copy to the next page here. No, sorry. So copy this one first. Go to the next page. Okay, I think this example is unexpectedly long. So here, now you compare, right? Now you compare something you already know. Okay, compare the equation dy dx plus px times y equal to qx. This is what in the chapter 7. Okay, chapter 7, we have something like this. So how do you compare now? What is a px now? You can say, alright, so from here I know px is equal to 2x now. Okay, your y become u now. Okay, you're solving for u now. Okay, px equal to 2x and qx is equal to 2e negative power x squared. Okay, so how do you continue with this type of equation? This is called a linear equation. So you find integrating factor, which I think we learned it first year. Anyway, just remember integrating factor is e power px dx. So integrating factor, your px is 2x now, so the e power 2x dx. So integrating 2x, you get x squared. Okay, just using power rule, x squared. And when you do integrating factor, you don't need the plus c after integration. Just this is your integrating factor now. So after you do integrating factor, so you plug this into the original equation now. So I'm going to multiply everywhere by integrating factor. So what you have is e power x squared multiplied by du dx plus 2x e power x squared. So multiply by integrating factor, multiply by u, and then multiply by e power x squared. Everywhere multiply by e power x squared, which is integrating factor. So and then you left with 2. Okay, 2 times e power minus x squared. Now, then you find that this e power x squared and e power minus squared, they obviously cancel each other. And the left hand side, you combine as differentiation of one term. What is that equal to? Differentiation of e power x squared times u, and then equal to. So the u is the one you select here. Okay, u here. You select u here. You select e power x squared here, and then multiply them. Then you should get the equation above by using product rule. Keep the first term, differentiate second term. Then you keep the second term, differentiate first term. Alright, so you can get until like this. Then to find the final answer, you integrate both sides now. So that means that eventually you get e power x squared times u is equal to integrate 2 with respect to x now. So this will give you e power x squared times u equal to 2x as a constant. So put it back together on the next page. Okay, on the next page, e power x squared times u equal to 2x plus c. So on the next page here, okay, e power x squared times u equal to 2x plus c. So you can find out what is u here. Remember, u is beginning y power minus 2. Okay, remember the here u is y power minus 2. Okay, the green color one. So that means that u is 1 over y squared. So that means e x squared 1 over y squared is equal to 2x plus c. That means that y squared times 2x plus c is equal to e power x squared. And so eventually y squared is equal to e power x squared 2x plus c. And this is the final answer. This is the final answer given in the